Hi everyone, welcome to section 6.2. I have a lot to cover in this video because we are going to learn how to multiply and divide radical expressions and how to simplify them. So this can get complicated. When I give you a rule, put it in your notes and remember it and practice it. And with practice, you can get good at this. So let's dive right in. If you are asked to multiply two radicals and the index number is the same, then you can multiply them, no problem. When you do, the index doesn't change. So if this is like a cube root, if this is a 3 and this is a 3, in your answer it's still a 3. But this radicand and this radicand can be multiplied like that and they can be combined. Let me show you with some real numbers. Here's the cube root of 6 times the square root of 2. This has an index of 3, this has an index of 2. You cannot multiply them. So you can't multiply them, you are done. Can't be multiplied. Here's another problem, the cube root of -4 times the cube root of 2. Both of them have matching indexes. They are both cube roots. Therefore, you can multiply them. This becomes the cube root of -4 times 2, or the cube root of -8. The cube root of -8 has an answer. It's -2, because -2 times -2 times -2 is -8. So this becomes -2. Here's two other problems we can practice. Here's the 4th root of 7 times the 5th root of 7. Can we multiply that? You should say no, because these indexes are different. Cannot be multiplied. Let's look at the next problem. 5th root of -5 times 5th root of -2. The indexes are the same, so you can multiply them. So it's going to be, your answer will be the 5th root of -5 times -2, or the 5th root of 10. And there's your answer. Okay, one of the trickiest things that you will be asked to do is to reduce a radical and make it in its simplest form, so that you'll get problems where they say, or show your answer in simplest radical form. There are some scientific calculators that'll actually do that for you, kind of cheating. Graphing calculators don't, so you're kind of on your own. So let me show you how to do it. Here's two different problems. I have the square root of 24 and the cube root of 24, and both of these can be reduced. So what you're going to do is you're going to look at this radicand, and you're going to say, since this is a square root, are there any factors of 24 that are perfect squares? And there are. This is 24 is 4 times 6, right? This is 4 times 6. And 6 is a perfect square. It's 2 squared, isn't it? So what you can do is actually pull this 4 out and put up here what is the square root of 4, or 2. And when you do that, your 6 will be left inside. So the 2 comes out in front, and left in the box is the 6. So some people will take this and they'll split it up into the square root of 4 times the square root of 6, which is perfectly legitimate, and then change that to 2, and it ends up being this. I just tend to look for my perfect squares that way. Yeah, I don't care which way you do. As long as you get the right answer, it's all good, but that's how you would do it with that. What about the cube root of 24? Well, 24 is 8 times 3. And 8 is a perfect cube. The cube root of 8 is 2. So again, I could do the same thing. I could pull this out in front, and the cube root of 8 will come out in front, and my 3 will be left inside. So now I have, 2, sorry about that, cube root of 3. And now I have simplified this one. These are equal, but this is in the simplest form. Okay, let's walk through this. One thing that will really help you, strongly suggest, take a 3x5 card. And if you don't have all the perfect squares memorized, at least up to 15, write them all down in the card. So 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, etc. Do on the other side, or on another card, do your perfect cubes. So write 2 cubed equals 8. 3 cubed equals 27. 4 cubed equals 64. 5 cubed equals 125. At least some of those, and so that you have that handy. Because what you're going to be doing is looking at these and trying to see if, for example, in this one, is there a perfect cube that's a factor of 54? And if you have that index card handy, it will really, really help. Because 54 it's 27 times 2. And you might not see that right away. And this is a perfect cube. 27 is 3 to the power of 3. So when we are going to simplify this, let's walk through it. Just take one part at a time. Let's just deal with the number. Since this is 27 times 2, I can pull this 27 out. And the cube root of 27 is 3. So it'll be a 3 out in front. And my 2 will be left inside. So I have the 3. Now, same thing we did before. I have 5 x's, x to the 5th. So remember before I showed you, you would divide this 5 by 3. How many 3's are in 5? 1. 3 will go into 5 one time. I can pull out 1x. Okay, 1x. What's my remainder? There's 2 left over, isn't there? So 5 divided by 3 is 1 with 2 remainder. So I'm going to have 2 x's left inside. So what I have then is 3x and the cube root of 2x squared. That's because this is 54 is 27 times 2, and x to the 5th is x cubed times x squared. So this 27 came out and became a 3. This x to the cubed came out and became 1x. And I was left with these two things in my radical, 2x squared. Be careful when you write these. Don't let the index look like it's a power. This is just 1x and that's the index. This gets confusing for students. Practice it. Let me help you if you need it, because simplifying radicals, there's just no other way around it. This is how you do it. Okay, now that you've seen me walk through it, let's walk through this again. Here's another one. It's a cube root again. Cube root of 128x to the 7th, and we've asked to simplify this radical. So what you're going to do is you're going to take that 3 by 5 card that you made, and you're going to look, are there perfect cube factors of 128? And there is. 128 is 64 times 2. And 64 is 4 to the power of 3. 4 to the power of 3 is 64. So this is 4 cubed times 2. So that means I can pull out my 4. That'll get rid of this 64, and 2 will be left in here. So I'm gonna just do this. Here's my cube root, and I've left the 2. So I've dealt with the number. Now I have x to the 7th. I have 7 x's, x times x times x times x, 7 of times. How many groups of 3 are in 7 that I can pull out? Well, in 7 there are 2 groups of 3, because 3 goes into 7 2 times. That means I can pull out 2 x's, or x squared. Right? Now when I pull out those 2 groups of 3, there's 1 remainder, isn't there? 7 divided by 7 over 3 is 2 with 1 left over. So that 1x stays in there, and I'm done. So it's 4x squared times the cube root of 2x. Okay, so now we have this multiplication problem, and we're going to want to simplify our answer. Notice these are both square roots. The index is 2, so that means I can go ahead and multiply all of this all together. So do the numbers. 72 times 10, so it is 720. So I have the square root of 720. X cubed times x is x to the 4th. Remember, when I'm multiplying, I just add the degrees. So this is x to the 4th. And y squared times y cubed is y to the 5th. Okay, now I've combined these into one radical. Now I want to simplify. So I'm taking my card and I'm looking for perfect squares. It might be tricky to see, but this can be divided by 144. 144 times 5. So the square root of 144 is 12. So I can pull that 144 out and it'll become a 12 out in front. Notice my 5 will be left inside. So I've dealt with the number. Now let's deal with the variables one at a time. Okay, I have x to the 4th. My index is 2. So 4 divided by 2, in other words, how many groups of 2 are in 4? 2. 4 divided by 2 is 2. So that means I can pull out 2 x's. So I get x squared. There is no remainder, so there will be no x left in the radical. I've taken all of it out. The square root of x to the 4th is x squared, right? Y. How many groups of 2 can I pull out of 5 since I have y to the 5th? So 5 divided by 2 is 2. I can pull out 2 groups of 2 again. So I have y squared, but I do have 1 left over, 1 y remaining. That has to stay in my radical. And here is my simplified answer. 12x squared y squared times the square root of 5y. Okay, well, let's move on to division now. We worked with multiplication and we realized that when our indexes were the same, we could go ahead and multiply. So a similar type of rule for the same reason applies with division, because they're the same things, just backwards, right? So if I have something like this, the square root of 18x to the 5th divided by, because that's what a fraction bar means, the square root of 2x cubed, look at the indexes. If the indexes are the same, I can write this as 1 root. So when I do that, it would look like this. And that is so helpful because that means I can actually simplify this fraction. So I can simplify 18 divided by 2, and it's 9. And x to the 5th divided by x cubed is x squared. So I end up with the square root of 9x squared. Well, those are both perfect squares because 9 is 3 squared and x squared is x squared. So this is just 3x, which looks so much simpler than that did. Here's a similar type of problem, only now we're dealing with cube roots. So I have the cube root of 162y to the 5th divided by the cube root of 3y squared. Since they're both, the indexes are the same, I can rewrite this as one fraction. Now that I have it as one fraction inside the radical, I can go ahead and simplify. So 162 divided by 3 is 54. So this simplifies to be 54. So I have the cube root of 54. And y to the 5th over y squared is y to the power of 3. And now I can find the cube root of 54y cubed. Now, if you have your index card, you're going to look, because we're going to simplify this, are there any perfect cube factors of 54? And there is. This is 27 times 2. And the cube root of 27 is 3. So I'm going to pull this out, and it's going to become a 3 out in front. And my 2 will be left inside. And 3 divided by 3 is 1. There's one group of 3 y's. So I'll pull out my y, and all that's left in my radical is the 2. So my final answer is 3y cube root of 2. Okay, here's your lesson check for today. Can you simplify this expression for me, please? And bring it in. Don't forget, we're still also checking to see if we need absolute values in our answer. Hint, hint. All right, so there's your lesson check. One thing that you're going to have to do with radicals is something called rationalize the denominator. It is not right, not proper to leave a radical in the denominator. We're not going to divide by radicals. So it's okay to have them in the numerator, that's not a problem, but not in the denominator. So when you have something like this, 1 over the square root of 2, you need to change it so that there is no radical in the denominator. And that you're going to do that by multiplying it by 1. So you're not going to change the identity, just the way it looks. So what you need to think of is, what do I multiply this by in order to get rid of the radical? And since it's the square root of 2, I'm just going to multiply it by the square root of 2. Because the square root of 2 times the square root of 2 is the square root of 4, which is 2. All right, the square root of 2 squared is 2. We're getting rid of this. I can do that as long as I multiply the numerator by the same thing. Now I'm multiplying by 1. Do you see that? So my numerator becomes the square root of 2, my denominator becomes 2, and I have rationalized the denominator. All right, let's say you are given a problem like this and you are asked to simplify this radical. And you look, it's already in one radical, this division, but you can't divide anymore. You have 5x squared over 12y squared z. So the only way really that you can simplify this, because you can't reduce it, is to rationalize the denominator. So the first thing we're going to do is we're going to split it up. Just like I showed you, I could have two separate radicals and combine them into one. I can go backwards. These are two separate, one combined into one. I'm going to make them two separate. So I have the cube root of 5x squared divided by the cube root of 12y squared z. The reason why I did that is because this denominator is what I need to rationalize, and I want to focus on it, so I separated it from the numerator. Now, what do I multiply this by in order to rationalize the denominator? So this can be tricky. So let me show you step by step how to do it. This is a cube root, which means in order to find its root, it needs three of the same factor, right? Either like an 8, 2 times 2 times 2, or a 27, 3 times 3 times 3, or a variable to the power of 3 so that we can pull it out. I need 3 of each factor in order to pull them out of this radical. So look at this, at what you have. 12 is 4 times 3, or 2 times 2 times 3, right? This is 2 times 2 times 3. And I have 2 y's and only 1 z. These are all my factors of 12y squared z. I need 3 of each of those in order to rationalize this and get rid of this radical. I must have 3 of each. I need 3 2's, 3 3's, 3 y's, and 3 z's in total. So look at how many I already have. How many more do I need? Okay, this, I hope you can track with me, because this, I lose students here in the past. Hopefully that won't happen with you. You can always rewind the video and replay it if you need to. I need 3 of each, so let's see what I need. I already have 2 2's. Since I need 3 total, I need just 1 more 2. So I need 1 more 2 to make 3. I have 1 3 already. I need 2 more 3's so that I'll have a total of 3. So there's my other 2 3's. Now, when I multiply, I'll have 3 2's and 3 3's. Do you see that? I have 2 y's. I need 1 more to make 3. I have 1 z. I need 2 more so that I'll have 3 z's. So basically now this is what I need to multiply by. I need to multiply the cube root of 2 times 3 times 3 times y times z times z. That's what I need to do. So 2 times 3 times 3 is 18. So I'm going to multiply this by the cube root of 18, 1y, and z squared. That is what I need. And if that's what I'm going to multiply my denominator by, I have to multiply the numerator by the same thing. Now that was the hardest part, figuring out what I needed to multiply by. So now that I've done that, let's go ahead and do one at a time. I'll start with the numerator. 5 times 18 is 90. So I have for my numerator the cube root of 90. And I have x squared and 1y and z squared. There's my new numerator. Now that's going to be over my new denominator. I have 12 times 18. Or instead of thinking of it that way, as 12 times 18, just remember it's 2 cubed times 3 cubed times y cubed times z cubed, right? So when I find the cube root of that, I find the cube root of 2 cubed is 2. This is a 3, a y, and a z. So I can pull out a 2, a 3, a y, and a z. 2 times 3 is 6. and this is a y, and that's a z, and there's my denominator. No radical. It's all gotten rid of because I multiplied. And believe it or not, this is simplified. Because that can be so tricky, I want to walk through this last practice too before I let you go. What is the simplified version form of this division problem? Cube root of 7x over cube root of 5y squared. There's no point in putting them together because I can't simplify 7 over 5. I can't reduce my x over my y. So all I'm left to do is rationalize my denominator. Remember, I go down to your prime factors and make sure you have 3 of each. And 5 is already prime, and I only have 1. So I need 2 more 5s. I need another 5 and another 5 because this is a cube root, so I need 3 of each. So I need to multiply this by the cube root of 2 more 5s, which is 25. I have 2 y's already. I need 3, so I have to multiply by just 1 more. 1 more y will give me the 3 that I need. So the cube root of 25y will enable me to get rid of this radical in my denominator. Since that's what I'm multiplying my denominator by, got to do the same thing to my numerator. Cube root of 25y. All right, now let's go ahead and deal with my new numerator. It's going to be the cube root of 7 times 25, or 175, and then x and y. And there's my numerator, and my denominator becomes my 2 prime factors, 5 and y. And I'm good to go. So that's what section 6.2 is all about. It can be complicated. Radicals can be fun, and they can also be tormenting. But work with it the best you can. Be patient with yourself. Take your time and ask me all the questions that you need. And I'll see you guys next time.